It's been a while since we last talked about science popularizers, but they do some important work. Researchers are in their academic cloisters expanding the horizons of human knowledge, and popularizers communicate that knowledge to the rest of us. A weird thing happens, though, when popularizers share that specialized knowledge with us. Some people accuse them of dumbing it down. They seem to think that somehow by sharing knowledge, popularizers are watering it down, distorting it, or making it somehow less good than it really is. But as Jeannie Fonestock argues, it is possible to epitomize a scientific argument in a non-trivial way that preserves the core of the research design. Therefore, any failure in the presentation of the core argument may represent more of a failure of will or of art than the inherent inaccessibility in the material. That is, if you think regular people just can't understand your research, it's not because you're an untouchable genius, it's just because you're bad at explaining it. But of course, we wouldn't be talking about this at all if people already agreed on that point. I've probably shared this before, but in the earliest days of this show, I shared one of my videos with one of my former professors to ask for feedback, and his response was kind of interesting. He said that he was basically confused by it because on the one hand, the video seemed kind of playful and lighthearted, as if it were made for a general audience. But on the other, it was about the rhetorical theory of Kenneth Burke, which, as he said, he didn't even talk about it at all with undergraduates because it was way too complex for them and definitely too complex for a general audience. So what was my takeaway? Well, according to him, the general public isn't smart enough to understand Burke, and academics are too joyless to have any fun with it.
So then you went and combined the worst elements of both into one show. Way to take the feedback, bud.
Well, obviously I didn't take the feedback because it was fundamentally at odds with what I wanted to accomplish. I mean, imagine what would happen if 3 Blue 1 Brown deemed the public too dense and never made a video called Group Theory Abstraction and the 196,883 Dimensional Monster. Or Native Lang doubted the public's ability to grasp the historical linguistics behind reconstructing the sounds of ancient Egyptian. Or if Niall Red thought the ins and outs of laboratory chemistry were just beyond the reach of the average viewer. See, when I was doing my research on popularizers, I discovered an interesting pattern. Not only are effective science communicators not dumbing things down, but they also do a lot to affirm their audience's intelligence. That is, instead of insulating their audience from the real science, they trust their audience to handle even some of the things that more old-fashioned academics might deem too advanced for undergraduates and laypersons. So I want to take a look at a few of the ways that effective popularizers acknowledge and affirm their audience's intelligence rather than talking down to them. But before we do, I want to show you how you can improve your own science literacy with today's sponsor, Brilliant. Like the best science communicators, Brilliant believes that successful learning is within anyone's reach, and they've created a learning platform to help you excel in math, computer science, and more through personalized experience with practical problem solving. I've been enjoying Brilliant's lessons on logic in an effort to better understand my colleagues in philosophy, and I've been impressed that Brilliant helps you learn by doing. Rather than just sitting through abstract explanations of formal logic, I've been right there solving logic problems and training myself not just to know about logic in theory, but to really understand it in practice. In fact, Brilliant's practice sets and reviews are crafted by award-winning teachers, researchers, and professionals. Real people with real expertise. As I've spent time with it, I've been happy to see that it establishes foundational knowledge and then builds on it step by step, making sure that you're increasing your understanding and reinforcing what you've already learned along the way. Plus, you know, if they can make learning formal logic fun, they're doing something right. So if you want to polish up your skills or learn something new, use the link in the description or the QR code right on the screen for a 30-day free trial and 20% discount on an annual premium subscription, and see how Brilliant can help a bright, inquiring mind like you to achieve your learning goals this year. Actually, speaking of bright, inquiring minds, check out this 3 Blue 1 Brown video entitled, "But Why is a Sphere's Surface Area 4 times its Shadow?" Clearly, he doesn't think his viewer is a know-nothing dum-dum. The title already assumes that the viewer knows how to calculate the surface area of a sphere. This isn't a video that dumbs things down, it's a video that deepens a viewer's understanding of something that they already know. But it's not just that. Once we're in the video, we see some signs that 3 Blue 1 Brown esteems his viewers as thoughtful, intelligent mathematicians, and not just as unwashed laypersons. And to show you what I mean, hey bud, what do you say? For old time's sake, you want to fire up your projector vision?
I thought we were done with that indignity.
Oh, come on, one more time won't hurt you. Besides, it's a very cool and impressive power, and you should show it off.
Ugh, fine, let me get get it set up.
Well, while he's doing that, the first half of the video shows us a classical walkthrough of the geometry behind calculating the surface area of a sphere, and we get to see some lovely graphics and animations along the way. Already, the mathematics communicator is not insulating viewers from the actual math. But as we press on, something interesting happens.
Now, if you're really thinking critically, you might still not be satisfied that this shows us what the surface area of the sphere is, because all of these little rectangles only approximate the relevant areas. Well, the idea is that this approximation gets closer and closer to the true value for finer and finer coverings. And since for any specific covering, the sphere rectangles have the same area as the cylinder rectangles, whatever value each of these two series of approximations are approaching must actually be the same. I mean, as you get really aggressively philosophical about what we even mean by surface area, these sorts of rectangular approximations are not just aids in our problem-solving toolbox. They end up serving as a way to rigorously define the idea of area in the context of smooth, curved surfaces. This kind of reasoning is essentially calculus, just without any of the jargon. In fact, I think neat geometric arguments like this, which require no background in calculus to understand, can serve as a great way to tee things up for new calculus students so that they have the core ideas already in their head before seeing the definitions which make them precise, rather than going the other way around.
So you probably caught it, but look at what he does. At the start of that segment, he acknowledges that his viewer has probably realized that visualizing the surface area of a sphere in terms of a bunch of tiny rectangles is only an approximation, not an exact measure. Now, whether the viewer has actually caught that or not, the video treats the viewer as the kind of person who would. And from there, we're just a short hop from that realization into calculus. And you probably noticed this as well, but his approach to calculus isn't framed in terms of the math is too complex for you, so I'm avoiding the calculus to keep it at your level. Instead, the framing is, I think this is a better way to introduce you to the underlying principles of calculus. It's not that you're too stupid to grasp it, it's that there's a better way to get you into it. So this video is not hiding the real math, and it's not treating the viewer as an ignorant tourist in the world of math either. This video wants the viewer to understand and appreciate the concepts, and it wants to build a road for the viewer to access that understanding and appreciation. The viewer is not someone who can't handle the math. They're someone who just doesn't know it yet, but totally could. And check out some of these comments too. It's clear that the viewers of these videos are not just understanding the concepts, but they're also being engaged by them. In her early scholarship on science communication, Fonestock argued that the popularizer's two greatest tools are to show the audience why specialized knowledge is useful, and to inspire in the audience a sense of awe or wonder. And this is a small sampling of the comments, which are themselves a small sampling of the over 8 million viewers of the video, but they make it clear that the viewers do not feel talked down to. The video has not dumbed the math down for the masses. Rather, it has assumed that the audience is intelligent and capable. The creator doesn't need to protect the viewer from the rigors of real math. Instead, he assumes that they can handle it and then finds a way to give them access to it. Now that's a far cry from the professor who said that his undergrads couldn't handle Burke, so I shouldn't make videos about him now, isn't it? But of course it's not just 3 blue, 1 brown. Look at how native Lang respects viewers' intelligence and lets them write into the methods of historical linguistics while answering the question why Danish sounds funny to Scandinavians.
Its words show off another Danish change. Unstressed vowels are getting weaker. This is how your nicely distinguished endings in Swedish and Norwegian will all end up in Danish with Meanwhile, the Hanseatic League is uniting to dominate the continent's northern coast, which brings a war and many new words from Middle Low German, or Middle Nether Dutch. Also, meanwhile, another change is happening in Denmark. Consonants becoming softer, like how t softened to th in matr to mad. This is lenition. It's a normal change, just ask Spanish, but weirdly, Danes do it at the end of syllables. Consonants and unstressed vowels are weakening, but stressed vowels are multiplying. By count, Danish will end up with more distinct vowels than maybe any other language. Now this is a Danish that's getting different.
See, there's no assumption that viewers can't handle jargon like lenition. Rather than avoid it, native Lang introduces them to it. And rather than insulate viewers from technical tools like the phonetic alphabet, the video just throws a vowel chart up on screen and trusts viewers to be able to grasp what they're seeing. Sure, maybe not as immediately as a trained linguist might, but the high front vowels are where high front vowels go, and this popularizer of linguistics hasn't opted to dumb it down with an E as in B chart. Instead, the viewers have access to the technical tools, and over 3 million of them are all in. But we might see one of the more dramatic examples of refusing to dumb it down in the work of Niall Redd. Just observe this excerpt from the first part of a 47-minute video.
Something that I've always wanted to do, though, was turn plastic gloves into grape soda. At first, this might seem a bit ridiculous, but like all of my other transformations, it's possible because the chemical world is often weirdly connected. In this case, there happens to be a chemical in plastic gloves, specifically vinyl ones, that's distantly related to fake grape flavor. It's not found in every vinyl glove, but a lot of them contain something called the phthalate ester. It's included to make the vinyl more durable, soft, and malleable, and this is chemically what it looks like. This, on the other hand, is one of the most commonly used fake grape flavors called methylene-thranolate. Considering that one just smells like plastic and the other is supposed to smell and taste like fruit, they're shockingly similar. There are at least a few main differences, but the core of them is almost the same. They share this ring and this small portion here, and in theory, it should be possible to convert one into the other.
I know you see it, but look at how we don't get a dumbed down version. It's not, now listen children, stretchy gloves have chemicals in them and I can do science that's way over your head to transform those chemicals into another one that tastes like grape soda. You like grape soda, don't you? No, we get the molecules and the jargon, and as the video progresses we get the step-by-step demonstration of synthetic chemistry with more charts and more jargon. This is not dumbed down chemistry for baby brains, it's chemistry for intelligent viewers who just happen to not be laboratory chemists. But listen here, ding dong, that's not real chemistry. So he sprinkled some jargon in there and showed some charts, but that's not turning his viewers into competent chemists. He dumbed it down. It's an unserious demonstration, but it's not real science. Well, who died and made you the arbiter of real science? And no, if we're talking about science narrowly as a method of inquiry, you're right. This video is not really expanding the boundaries of human knowledge of chemistry. But let's be honest, how many people actually use science that narrowly these days? More importantly, we're not claiming that science popularization and science research are the same thing. But as Hilgartner points out, recent work has argued that scientific knowledge is constructed through the collective transformation of statements, and popularization can be seen as an extension of this process rather than an entirely different one. Popularization and research are not the same, but they both fit under the larger umbrella of science. And that's the key. Popularizers aren't trying to create knowledge in the way that researchers are, and they aren't really trying to train the next generation of researchers in the way that teachers are. Their job description is in the name, to popularize, to get people interested, to get them invested, to show them the version of science that is an added value to their lives. It makes me think of one of the best classes I took in college. In order to complete my physical science requirement, I could have taken general physics like most people probably do. But instead, I chose to take a course about acoustics. Not only was it a course that filled a general education requirement, but it also was required for music majors and speech pathology majors, and of course the professor knew it. So he had a choice to make. He could teach a version of acoustics that was designed to prepare the next generation of academic acousticians, or he could teach a version of acoustics that would be useful to musicians and speech pathologists. He chose to do the latter, and he did a great job. Now, I can imagine some physicists grumbling that he was dumbing down the class, but that's not what he did. We still studied waveforms and did calculations, but instead of learning everything we'd need to know to do our own research in acoustics, we learned what we need to know to understand the resonating frequencies of clarinets and the formants and vowels. Now, of course, the silliness that's bundled up in the distinction between pure science and applied science is not something I can cure in this video. But ever since I took that class, I've admired that professor's willingness to teach what he cared about in a way that also served what his students cared about. I mean, way too many people teach general education courses as if they were introductions to a major, and way too many people think that making knowledge useful and accessible is dumbing it down. Never mind the fact that that physics class probably produced smarter musicians and speech pathologists who were already good at what they were doing and then got even better at it thanks to that added dose of science. So, as it always does with rhetoric, the choice comes down to this. Is your specialized scientific knowledge about your ego, about drawing division between the learned elite and the ignorant public who just can't handle the rigors of your genius? Or are you so motivated by how exciting and useful your knowledge is that you want to share it with everyone, even if it means pushing yourself to find new ways to explain it and bring people into the fold? Now, I won't say that one way is better than the other, but I don't need to tell you that I spend my weekends making videos for the internet rather than attending academic conferences, so draw your own conclusions.
No, this is worse. So much worse. Imagine a timeline without this weekly exercise in boredom and anger. Actually, don't. Don't give me that hope.
Well, anyway, in the end, I'm much more equipped to talk about the rhetoric of science than the science itself. So if you're looking to build or strengthen your scientific knowledge, don't forget to check out Brilliant at the link below. And either way, just remember, your audience is made up of smart people who can handle a lot. So don't be shy about sharing what you know. And I'll look forward to sharing more of the little that I know with you next week.